Hello everyone, I hope everybody is fine. In this lecture, I'm going to show you some examples where we will be using the laws of logarithm. We have studied all the laws of logarithm in the past. We know them, we know the formulas, and we just want to do some practice questions to see how we can apply those laws of logarithm in doing a variety of problems. The first question, it says express as a single logarithm. So we have 1/2 ln of x, that's a natural logarithm of x, with the base e, of course, as you know, minus 4 times ln of y, plus ln of x squared plus 1. So there's 3 logarithms here in addition subtraction form, and using the laws of logarithm, we have to sort of simplify and express the answer in the form of a single logarithm without touching a calculator, of course. Okay, so what we're going to do, we are going to use the power law of logarithm first. So the coefficient becomes an exponent for the argument of the logarithm. So we're going to have ln of square root of x here, because you know that x to the exponent of 1/2 is actually square root of x. And then here we're going to have minus ln of y to the 4. Again, the coefficient becomes an exponent. And then this one doesn't have any, so it's going to remain unchanged. So this is the first line we get. And then we continue, and we notice here that we have a difference of 2 logarithms. And that reminds us of this law right there. It's called quotient law of logarithm. It says log of a quotient equals to the difference of the logarithms. So here we have a difference of logarithms. So it's going to be ln of root x over y to the exponent of 4. So this is just like ln of m over n, which is equal to ln of m minus ln of n, naturally speaking. And then the last term remains unchanged. And now we see the sum of 2 logarithms. And this reminds us of this other law of logarithm, which was called product law of logarithm. We know that the sum of 2 logarithms is equal to the logarithm of the products of the arguments of those logarithms. So here, this is going to be equal to ln of square root of x times x squared plus 1 all over y to the exponent of 4. And as you see, this is a single logarithm. So we were supposed to express this logarithmic expression in terms of a single logarithm, and that's what we did. Next exercise is very similar to that one. So we have log of x squared, and then minus log of x squared minus 1 raised to the exponent of 1/2, that's the coefficient, and then plus log of x squared plus 1 cubed, actually. So this time I can take the first and last logarithms, I can add them. So using the the product law of logarithm, I can say this is basically log of x squared times x squared plus 1 cubed, okay, and then minus log of square root of x squared minus 1. And then we see the difference of the 2 logs. So using the quotient law, we would say log of x squared times x squared plus 1 cubed divided by square root of x squared minus 1. This is going to be the final answer. Square root of x squared minus 1 goes in the denominator. And now we see that we expressed this relatively complicated logarithmic expression in terms of only one single logarithm. The base is not mentioned. Obviously, it's common logarithm. That is, the base is 10. Next question is an evaluating question. We need to evaluate this expression. So again, we're going to use the laws of logarithm. We're going to say 9 to the exponent of 4. Log of 9 to the exponent of 4 becomes 4 times log of 9 base 3 plus this one is going to be 2. And then you know that square root of 125 is actually 125 to the exponent of 1/2. But then that 1/2, that exponent becomes a coefficient for the log. So we end up with log of 125 to the base 5. And the 1/2, which was the exponent, becomes a coefficient for the logarithm. and then we're going to multiply that by 2 later on. This one, similarly, is going to be negative 2 log of 10 to the exponent of negative 3, because 0.001 is 10 to the exponent of negative 3. And I think you notice that we don't even touch a calculator. We are only using the laws of logarithm right there. So log of 9 base 3 is clearly equal to 2, because 3 squared is equal to 9. So that would be 4 times 2. Okay, log of 9 base 3 is equal to 2, because 3 squared equals 9, using basic definition of logarithm. 2 times 1/2 is just 1, and we have a log of 125, which is 5 cubed base 5, and then minus the exponent for the logarithm becomes a coefficient. So we have negative 2 times negative 3, and then log of 10. So we end up with 8, 4 times 2. 3 becomes a coefficient for the log. So we end up with log of 5 base 5. And then we have plus 6. And then log of 10 base 10 is equal to 1. According to this formula, log of b base b is equal to 1. So log of 10 base 10 is equal to 1. And log of 5 cubed, according to this law, the exponent becomes a coefficient. So 3 becomes a coefficient for the logarithm itself. And now we have log of 5 to the base 5, which is once again equal to 1, according to the other law of logarithm. As you see, we are using all of these laws of logarithm in every single question. So we're going to end up with 8 plus 3 plus 6, which is going to be 17, final answer. So without touching a calculator, we could evaluate this logarithmic expression.